Unit 7, Lesson 2, Rational Exponents. So in this lesson, we're going to learn how to deal with powers where the exponent is always a fraction. Okay, so for example, 4 to the power of a half, right? The exponent there is a fraction, it's a half. So we're going to learn how to deal with this. And the way you deal with powers when the exponent is a fraction is the denominator represents the root that is applied to the base. So if the denominator is 2, that means we're going to take the square root of the base. Okay, and then the numerator is just the exponent on the entire thing. Okay, so a couple more examples. We have 125 to the power of a third. So the denominator becomes the root. That's why we have a third root applied to the 125. And then the numerator is just the regular exponent that it's raised to. Okay, so because the numerator is 1, it doesn't really affect the question, but we still have to be aware of what it is for. Okay, 27 to the power of 2 over 3. So the denominator is the root, so that means we're going to take the third root of 27, and then the numerator is the regular exponent, so it's going to be all squared. So to solve this, you'd say, okay, third root of 27 is 3, and then it's squared, so our answer is 9. Okay, let's try example 1, part A. Negative 8 to the power of a third. So the denominator is the root. So we have the third root of negative 8, and then the numerator is the exponent that everything is raised to, but it's just a 1, so we can basically ignore it. It does nothing. Because anything to the power of 1 is just anything. Okay, so the third root of negative 8 is negative 2. Okay, let's try part B. So 9 over 16 raised to a half. So the denominator is 2, so we're going to take the square root of everything. And our numerator is just 1. So the square root of 9 over 16, you take the square root of the numerator and the denominator, is 3 over 4. Okay, and finally, 16 to the power of a quarter. So our denominator is 4, so we're going to take the fourth root of 16, and it's just another button on your calculator. Okay, numerator is just 1, so that's kind of irrelevant right now. Okay, and our final answer is 2. Okay, so in general, when you have a base raised to a power that is a fraction, okay, here's how you evaluate it. So the denominator of the fraction becomes the root, and the numerator of the fraction is the regular exponent. Okay, so we always dealt with fractions where the numerator was 1, so this didn't really apply to us yet, but in the examples that we're about to do, we're going to have to become very comfortable with applying that exponent as well. Okay, so 25 to the power of 3 over 2. So our denominator becomes the root, so it's the square root of 25, and then the numerator becomes the power. So now it's not 1 anymore, so now we have to apply that. Okay, so the square root of 25 is 5, and that's cubed. So our final answer is 125. Okay, this time the denominator is a 3, so that means we're taking the cubed root of 27, and then our numerator is a 2, so it's all squared. So the cubed root of 27 is 3, and that's squared. So our answer is 9. Okay, we have a 5 in our denominator, so that means we're taking the fifth root of 32, and then we're going to raise it to the power of 4 because the numerator is 4. So the fifth root of 32 is 2, and then 2 to the power of 4 is 16. Okay, 16 to the power of negative 3 over 2. So because I have a negative exponent, I'm first going to eliminate that by turning this into its reciprocal form. Okay, now because our denominator is 2, when I write this as a root, it's going to be the square root of 16. And then because our numerator is 3, the entire thing is cubed. So the square root of 16 is 4, and then 4 cubed is 64. Okay, simplify the following expression. 8 to the power of 5 over 6 times the square root of 8 divided by 8 to the power of 5 over 3. So if I take the square root of 8 and work backwards and put that as a exponent that's a fraction, then I'm going to have a bunch of powers with the same base. So I can simplify first using exponent rules. So I'll show you what I mean by that. So the square root of 8 is the same as 8 to the power of a half, right? And if you don't believe me, let's work forwards again. So 8 to the power of half, right? Denominator means that we have a square root, and the numerator is just 1, so that's kind of irrelevant there. Okay, so that's how I worked backwards. Okay, and now I'm going to simplify my numerator. So 8 to the power of 5 over 6 times 8 to the power of a half. We're multiplying exponents with the same base. So I'm going to use product rule and add my exponents. Okay, now to add my fractions, I need to have common denominators. Okay, now if I simplify the fraction in my numerator, I'm going to get 8 to the power of 4 over 3 over 8 to the power of 5 over 3. So when I'm dividing powers at the same base, I'm going to use my quotient rule and subtract the exponents. Okay, now because it's a negative exponent, I'm going to turn it into its reciprocal to eliminate that negative exponent. And finally, this turns into 1 over the third root of 8, which the third root of 8 is just 2, so we get 1/2.